Okay, while everyone's finding their seat, we are going to do another giveaway. What do we got here? Oh, okay. Is anyone familiar with the Uno R3 starter kit, little electronics board? Is it an Arduino? Oh, yes. Anyone? Never heard of Arduino. Sounds dumb. Anyway, if you want it, make note of your seat number, and I'm going to pull out a randomly selected piece of paper. I mean, it's somewhat random. Okay, can anything in life really be random? Is the universe deterministic? These are questions I must know. Row H. B, C, D, E, F, G, H. Can you see yourselves, row H? Okay, number 22. Who is it? That's you, I think. Congrats, come get your Arduino. Have fun. Okay, time to introduce our next speaker. All right. Our next speaker is Scott McAllister. Scott is a developer advocate for ngrok. He has been building web applications in several industries for over a decade. Now Scott is helping other teams to learn about a wide range of web and infrastructure technologies. When Scott is not coding, writing, or speaking, he enjoys long walks with his wife, skipping rocks with his kids, and is happy whenever Real Salt Lake, Seattle Sounders FC, Manchester City, St. Louis Cardinals, Seattle Mariners, Chicago Bulls, Seattle Storm, Seattle Seahawks, OL Region FC, St. Louis Blues, Seattle Kraken, Barcelona, Florentina, Borussia Dortmund, or Mainz 05 can manage a win. Please welcome to the stage, Scott.
Well done. No one has actually read the whole list before. But if you paid attention to that list, you can now see where I've lived, basically, or visited. And so you know that I'm Scott McAllister. I come from Seattle, Washington, but I did spend some time here in the great state of Utah. In fact, I'm an Aggie. Anyone else in here an Aggie? Woo! Oh, sorry. That was really loud. Aggies all the way, right? Okay. But I need you all to help me out real quick before I get started, because my boss sends me to these conferences to give these talks, and I have to justify that I actually came here to Salt Lake to do work. So if you all could smile and wave. Awesome. Perfect. That way we can know that Scott did good things here. If you are here in this room, laptop? You know what? It really helps. Hold on. I technology sometimes. I write software. I talk about software and hardware. But sometimes when you connect your laptop to the projector, it makes it so you can actually see it throughout the rest of the room, doesn't it? So if you're here right now, you're here to learn a little bit about API gateways. But also, since I'm in a movie theater and we're all here together inside of a place where we normally watch beautiful people act out things, we are going to elicit the help of a couple of movie stars to help us tell a story, or at least help us understand a little bit more about API gateways. So the hope is by the end of the 40 minutes we have together, that you enjoyed it a little bit, maybe reminisced a little bit. For me, this is a movie that came out when I was a teenager, so it's near and dear to my heart. But that also you have a better understanding of API gateways, and possibly, if you're in the process of evaluating them, you can kind of have a better idea of how to evaluate what you need and what you don't. So to start, I want to start with a story. Fictional story of a startup where, imagine being on a team where you have developed a new service. You have an API that you are so excited about. And it is the most beautiful thing you've ever written. And no one can tell you it was ugly. Even if it was green and had little things sticking out of it, it was not ugly, it was gorgeous. And you knew that once the world saw it, that they would feel the same way too. And that people would use this thing and it would change the world and you would be the next great software startup. And so when you built this thing, you put it out online, you thought, well, I want it to be resilient, so I'm going to put a load balancer in front of it. Make sure that it's available, that we can route traffic to different instances of it so that we can say that it's online all the time. And that seemed to work. So you release a public beta, it's free. You want users to use the thing. You want feedback. And people did. Oh, the people came. You built it, And they came. And as they came, you thought, all right. So you and your team, your small team of engineers, you came into that small conference room and you started having a meeting where you're thinking, okay, so this thing not only has little green weird things sticking out of it, it has legs. And people like it. And they're starting to request features. We're getting all these feature requests coming in from the people that are using our API. All right, we got to start thinking about how we can make this thing stable and continue on with it. So you're thinking, all right, well, we sort of addressed availability, right, when we put in our load balancer at the beginning, but even with that load balancer, sometimes that got a little wobbly and fell over once or twice. So you're thinking, well, maybe we should add some rate limiting or some circuit breaking. So if we start getting really excited user or really not nice user starts hitting it a lot, we could break that off, make sure that's there to help it stay up for everybody else. So you're in this little conference room. We've all been in that conference room, right? Tiny little conference room where you start putting Post-it notes on the wall. Right. We have all this software that helps us manage projects, Jira and whatever, but we always start brainstorming by putting Post-its on the wall. And so you're thinking, okay, rate limiting, boom, put that on the wall. Circuit breaking, boom, put that on the wall. All right, so thinking about more resiliency, things to keep our gateway, keep our API, I gave away the ending, keep our API a little more stable. You're thinking, okay, well, we have all these feature requests that are coming in, and some of them are actually breaking changes. Some of them are actually making things that are different than what we have today, so what are we going to do about versioning? How are we going to handle that when folks are coming to our API and really we need them to go to different endpoints, we need them to send different arguments, different parameters, and there may be even some different responses coming back. And so how do we handle that versioning? Do we just send a message out and say, sorry, breaking change, you're going to have to change your code because we're changing ours? Or do you want to put in maybe some dynamic routing to say, well, if you're going to be asking for this endpoint, why don't we route you in the back end to actually the service that we want you to use, the new service, the V2 service? So let's put in some URL rewriting or some redirects inside of our API. So add those Post-its to the wall. And finally, this thing's nice. It's free, so anybody can use it, but we need to pay the bills. We need to eat, as we all do, and so we're going to be charging a little bit, so we need to actually put some security around it to decide, okay, which users can use which parts of the API. Maybe this will be a free feature, but this will be a paid feature, so we need to put some job validation in the way. So we need to integrate that into our API as well. Okay, that Post-it note goes on the wall. And all these Post-it notes are big Post-it notes, and they have lots of little sub-Post-it notes all around them. And you're sitting there looking at it thinking, okay, so how do we do this? We could start adding these things to our API and to our infrastructure here and make that work. And so you and your little team, probably a team of 2, we'll just say, to keep the story simple, you start, as we do, we look around on the internet, we talk to folks, we look at different discussion boards, Reddit, whatnot. You might even come to a rad conference at Jordan Commons and hear about a thing called API Gateway. And you're thinking, wait, this makes sense. I could put a gateway, something in front of my API to make it so that it would route traffic to my API, but it can handle all those things. It can handle the rate limiting and the load balancing. It can handle the authorization and authentication, and it would be separate from the rest of my application. It would be my single point of entry, and then my API I could do what I wanted to do with my complexity of my API, but have my gateway there to make it a more consumable thing for my users. I love this diagram. I didn't make it. I'm not even associated with ByteByteGo, but the folks at ByteByteGo is an educational site online. They made this diagram. While I love it because it moves, so it kind of keeps your eyes kind of interested, it explains an API gateway quite well. We have your clients. Doesn't matter what your API is consuming from. You have your web clients and you can have a desktop client, maybe a mobile app. But then that gateway will handle our authentication, our authorization. It can handle our service discovery, dynamic routing, even handle requests with our external services that we're using inside of our application. And you're looking at that and you're like, yeah, that's what I want to do. In fact, that's what it looks like as a diagram. And then I want to show you, if we pop out of my slides for just a second, Because as developers, we like seeing things, we like seeing code, right? So an example of how an API gateway could be configured, a lot of them are configured with YAML, because YAML is our universal configuration language. It seems to be configuring everything these days. And so with this is an API gateway that's provided by my company, ngrok. Promise this isn't going to be a commercial, but just showing you an example of what you can do with a gateway in general. So in this case, I have 4 different expressions, 4 different actions that I'm going to be taking. 3 on incoming requests, 1 on responses, things I'm sending out. So in our case here, I have my jot validation. VS Code does that nice little thing where it takes the top, but I don't want that right now. So if we look at my expression here, I'll just point here on my screen. It can be granular enough where you say on just post requests and on this, in this path, we want to require that there is a token, that it's passed in the header, and then we're going to use auth0 to handle that. We're going to offload our authentication to auth0 because they're the experts on that. We're not. And so that's easy. That's nice. So I can take that and we'll take it to our API. And that way, when we make posts to that API, that we have to pass in a valid authorization bearer token there in the header. Then also we can set up some rate limiting. If I'm doing a demo, I can say, let's do only 3 requests for every 60 seconds. Obviously, we don't do that in production unless you don't like your users. It just depends. And so in this case, if you want to actually see it happen, you would say 3 in the next 60 seconds from a single IP address. Or we also have our dynamic routing. If we have a deprecated endpoint, something that we want to take and say, well, you were going to the collections endpoint on this particular application. This API for this example is a vinyl record collection that you're keeping track of. And so you say, well, we're going to talk about collections, but really, that's the base of the whole app. So we're going to reroute you on the back end to actually just go to our base. And so with the URL rewrite, it just subtly does that for you without you really understanding what's going on as a client. And that's OK. You're OK with that. And then finally, we have custom error pages. If we want to just say, you know what, if there's an error on this API, I'm just going to say, let's cut you off here, and we're going to send back a specific error that we have here. We're going to set the status code. 418 is a real status code, and it's the best one out of all of them. If you don't know what it is, you can look it up, even right now if you want. It's great. It's real. It's not a joke. It is a joke, but it's real. And then we can put our custom error messages there. So that's what an API gateway would look like if you want to configure it, just a simple one, a simple configuration in code. Okay, coming back to our slides. Different types of API gateways. When I was doing my research, when this team was doing its research, it depends on who you talk to. And in a lot of places, they'll say, oh, there's dozens of different types of API gateways. And that's true if you want to get into the nitpicky details. But there's also really what that happens is they kind of boil down into really 2 groups. And there's kind of a fuzzy one in the middle. Fuzzy enough that I didn't actually put them here on the slide. And that first group, the deployable group, the deployable gateways are the ones that you would install on your infrastructure. You would take a thing, install it either in your data center, on your box, or in your EC2 instance, and you would say, let's use you as a gateway, it'll configure you, and then make it so that you can be a gateway for the rest of my API. Those are super powerful. That's why people use them. Because you have so many nerd knobs that you can turn that you can make it so that it actually does exactly what you want it to do. But they have a super steep learning curve, they tend to, and plus they have lots of dependencies. We'll talk about those here in a little bit. That second group, the cloud ones, those are basically the gateways that are associated with your cloud providers. So if you're an AWS shop, you've probably heard of Amazon's API Gateway, which is essentially an extension of its API manager. And so it's like, it just adds that functionality into your application. If you are all in on a particular cloud, that is absolutely the type of gateway you should go with. That way, because you're already there, it's like taking it off the shelf and saying, yep, that's the one of the thousands of things I can add to my application, I'll just use that. They're super easy to set up. They have a few less features. And so that's why why folks they'll probably start with one of those and then say, well, it doesn't have everything I want. So they might look at a third-party vendor, more of what are the deployable ones. And then I mentioned that middle ground. hybrid API gateways is what I've been hearing and reading about lately, where they're not quite a cloud one. I mean, they are running in a cloud, but not one of the major cloud providers. And they're a third party, so there's sort of a hybrid in there. That's kind of where ngrok sits, but that's kind of what happens there. So as you're doing this research, you sit there and you say, and you're sitting there with your engineer coworker in that conference room, you're like, wow, that's a lot. Maybe a little overwhelming, maybe a little underwhelming, maybe you're just whelmed. Okay, a couple of you watched the movie. If you didn't, it's okay. But so you're starting to think, okay, so this API gateway thing, let's look into this. Let's journey into this. Let's see how we can build this for ourselves to make it work for us. And what I'm going to do is I'm going to talk through their journey, but I'm going to relate it to relationships, because that's what it said in the description, right? We're going to relate API gateways to those tumultuous times in those teenage romance movies. And so a lot of the things that I'm going to talk about, the pain points, they might be pain points for a particular time or for a particular group, but they may also be a benefit at another time and for another group. So some of you up here will look at one of the slides I'm about to go through and be like, well, I actually like that. I want that in my API gateway. And so that's fine, because that'll be a good fit for you. Sometimes software and other things, relationships in general, it's just a bad fit. And we have different goals than what the software does, and so we should look for software that has similar goals than we do. So the first thing that this group tried to do is they looked at that wall, and they said, okay, looking at all these Post-it notes, we could do this, right? It's not mind-bending stuff to write. And so it's fairly self-explanatory, I mean, as far as we know. And we was like, yeah, I could write. I mean, I wrote the load balancer. I could probably write some rate limiting into there. I could hook into some authorization or authentication service. But then you look over at your coworker at the other wall, and you see the other wall behind that coworker, and you see the other Post-it notes that were already there. The feature requests that your customers wanted, the other features that you were going to add to your API. Oh yeah, I have those too. So now you have to think, now I have these gateway features that I want to write, and then I have this other wall with feature requests that I need to write. Something is going to have to give. If you start going into here, then something's not going to happen over here. That goes into some of our why nots of building your own API gateway. The biggest thing is the time and the money. The time and the money, the fact that you're going to write it, then of course you're going to write tests for it, because we all write tests for every bit of our software that we write, right? Yep. And then documentation. Yep. We're going to document every piece of it, because that's just what we do. But I mean, building a thing is one thing. As we software engineers famously say, it's like, I could crank that out in a weekend. Probably could. But then you get to maintain it. And there's that there. And not only that, when you start looking at that left column where you're saying, all right, well, what about, am I really a security expert? Do I really understand this stuff intensely? I mean, I understand it now, but what happens when things change in a few years? I'll have to get ramped up on that type of security set, or that type of security that I need to watch out for. And so you have to continually be learning those things, taking your time away from the feature requests and focusing more on building your gateway. Same goes with monitoring. Same goes with scaling with your application. As you add new features to your API, you'll probably need to add features to your gateway. And that's what these folks discovered. And so they decided, okay, well, let's look at one of these deployable API gateways. They started looking into that, and they started saying, oh, geez, there's a lot here. I mean, I can configure the gateway with some YAML, but then, as an example, there's an API gateway called Kong. And Kong is a great API gateway, super powerful. It has a variety of installers. It can install on practically every operating system. They have Docker containers that can go into practically every environment. And so it's super easy to get started. However, they also have a laundry list of dependencies, Cassandra and other dependencies that you have to configure to get it running and to keep maintained. So you have to say, okay, I have to understand that stuff and the YAML. But again, it could provide the power that I need. But you're thinking, well, I don't know. Do I want to have all that power or have all this time to configure those things? Or should I look more back at the, maybe say an Amazon-based one or an Azure-based API gateway? Then your coworker, as you're sitting there in that conference room, looks at you and says, well, what about network overhead? I mean, we have all these features we're going to be adding that's going to be checking each HTTP request coming in. Isn't that going to slow traffic down? So you look into that, you do some research, and you realize, yeah, it does. But in the hundreds of milliseconds, usually. But each of the different vendors are different. So they had to go into each of the vendors and see which ones had what their benchmarks were, what their overhead was, as far as how much latency the gateway was going to include or introduce into their traffic. Whether that latency was going to be okay for the features that they would get on the other side. And then, as they were looking at the different gateways, they thought, well, we still need monitoring, though. We need to monitor our gateway, and that's not in these particular gateways we were looking at. So we need to add that too. And so one engineer thought, well, that's kind of dumb. I want to just have everything all in one package. But then the second engineer looked back at him and said, well, I already like using Datadog. We use Datadog for the rest of our application. Why not we just hook up our API gateway hook up Datadog to the API gateway, and that would work. So it would integrate in with the API gateway. So in this case, the additional customization was a pain point for one of the engineers, but yet for the other engineer, it was actually great that, hey, look, these particular gateways integrate well with the tools that we already own. When you're evaluating, you want to see which ones customize or which ones integrate well with yours. Kong has what they call a plugin development kit, PDK. So they allow you to write various plugins that can customize and integrate in with the rest of your system. I believe there's a company called API 6 that has its own plugin language. I think similar to HashiCorp has HCL for Terraform, that type of thing. They have their own plugin language for writing those types of plugins to customize your API 6 API gateway. So pain point for some, but honestly for others, knowing that I could integrate with the things I already have, maybe that's probably a good thing. Scaling is interesting. That's swinging back more and looking at the deployable gateways. Rather, because the cloud gateways, the whole reason we use are those clouds. The reason why we use AWS, Azure, GCP is because we put stuff there and then they can just grow with the traffic, right? That they automatically deploy or they automatically scale, and so they would just scale with your application. However, the deployable gateways, those you'll have to think about. You might have locations, maybe you might be set up in a region here in the United States, but then you need to be set up in a region over in Europe, so you got to set up your gateway again over in Europe, and then you have another region over in Asia, and you have to set up your gateway again over in Asia. So that you have to think about how you would scale with your gateway. Vendor lock-in, that's if you're worried. If you're already using a cloud like AWS, Azure, GCP, Oracle, IBM, if you're already using one of those clouds, you're probably okay with it. Okay, so if you're not real excited about that, you could be using one of the more deployable gateways. That way you can stay not as locked in with those. Or you could use something in the middle, one of the more hybrid ones that don't lock you into a particular cloud, but yet still aren't deployed. Multi-cloud. That was one of the engineers in the room said that and chuckled. And I'll admit, from my experience, every software company I've worked at, they say, oh, we should be multi-cloud, or oh, we are multi-cloud. And you say, oh, and you get there and you realize, you start talking to people and say, oh, so how are we multi-cloud? Which ones do we run on? Oh, we run on AWS. And nothing else, right? Oh, we used to run on Azure, but that piece kind of went out, we stopped using that one. I was like, oh, well, maybe we should work on multi-cloud. They're like, well, yeah, we should, but we're going to be adding features first. So I always find multi-cloud kind of funny. However, I had a conversation with a friend at one of those companies just recently, a couple weeks ago. And he said that, we, obviously, as you knew, we were all in AWS, completely Amazon shop. I mean, at this company, obviously we'd be an Amazon shop. The founders of the company came from Amazon, so we'd be an AWS shop. However, this particular application was growing, it's super big, and it started realizing that, hey, we need to increase our service offering, our product offering a little bit. And so we're gonna acquire this company over here that does a feature set that we don't. But guess what? That other company, yeah, they ran in Azure. So they had their own set of APIs that had their own API gateway. And then there's in addition to the regular API gateway that was running their APIs all on AWS. The story gets better because they ended up acquiring a third company, and of course that third company didn't run in either AWS and didn't run in Azure. Now they have GCP, all three big guns, all three API gateways inside of their infrastructure. And the gateways, which I thought were a single entry point for all your users, they now have multiple gateways, and they gotta keep those multiple gateways in sync, trying to keep things as far as like the experience, the user experience. They're trying to figure out how they can blend those together to make it a single experience that's positive for their users. And so he was realizing that they actually need to take a step back, and they're gonna be putting a gateway in front of their gateways so that that gateway can be that single entry point. And then it can route traffic to the various different APIs, but then they can have more universal experience there across all their different services inside of their applications, even though each one is running in a different cloud. Now, is it secure? This question that someone brought up, because when I was researching this talk and I was asking folks, like, what are the pain points you have with your API gateways? It wasn't asking, is the API gateway secure? Because that's like one of the three main tenets of API gateways. It's the reason why you get it is for security, load balancing, and routing. I mean, that's essentially why you start looking into API gateways. And so it isn't so much, is the gateway secure, but rather, are you secure using it? Are you the one, do you know how to use the gateway well enough to actually make it secure? And that's important because according to the Salt Security's State of API Security Report, 94% of production APIs have had security incidences. Incidents. I used to work at PagerDuty. They would make fun of me for saying incidences because, incident management. Anyway, sorry. I digress. 94%. Security is important. Make sure that you know how to use that gateway to make sure that the security to your API is enough. Troubleshooting. It's like, yes, it's a third-party application, so getting into it's one thing. But really, when you're thinking about troubleshooting, I'm thinking more of things like documentation, or the community, or the support reputation. If this application, if a gateway that you're looking at is relatively obscure, it's like, whoa, new shiny, it's written in Node, and it's using the latest framework, and it's so rad, and I know the person who wrote it, but like 12 people are using it. Yeah, unless you really know that person who wrote it, and then like you're in with them, sweet, perfect. But if you're looking at something, you want to think, okay, does this have a good community? Does it have good documentation that when I run into issues, can I see what the events are that are happening going into this gateway, coming out of this gateway? Can I make sure that I understand how to fix things? So how is my troubleshooting experience with the gateway? And the final one is the boss wants it. I mean, who's ever been in a meeting where you come in with this idea, it's like, we've decided on a particular vendor we want, and these engineers came into the room, they said, we want this gateway. And the boss is like, yeah, that's nice, but I have a friend over at Gateways R Us, and we're gonna use that one. And a lot of times you might sit there and think, okay, that's it. This is the boss person, they can say what they want, we do what the boss person says. However, I encourage that not to think that way. That didn't come out right. Think about how you can persuade upper management with your decision. As my boss likes to say, bring your receipts, right? Come with data, come with actual experiences that you have, but then also connect on a human level. Talk about your experiences as engineers, as you've tested out these different gateways. You've even tested out Gateways R Us, and you can say, well, when we worked with it, we had this much downtime, it took us this long to configure, and it didn't have feature X, Y, and Z. When we used another gateway over here. This one actually had these experiences that made us a lot better. When you have the data and you can connect on a human level, that can help persuade your bosses. So you come out of that meeting and you're maybe a little less optimistic. But I encourage you to be optimistic, because when you have a plan, when you're going into what you want to use with your team, figure out what you want, figure out what your expertises are. What is important to you with your API gateway? What is important to the fact of the skill set that you have on your team? How can the gateway help augment that? But then also take that, evaluate those options, and then plan for the future. Not necessarily, you want to look at the features you need now, but you also need to see what you need going forward. And when you find that good fit, it honestly feels like that great relationship. When you're in high school, you find that one person and you feel so good, you want to dance in front of the whole school and sing a song. I'm not going to dance in front of you and sing a song, even though last night when I was telling my friend I was giving this talk, he wanted me to recreate that scene, and I said no, because I don't sing and dance. However, these good feelings and this good fit might make you a little poetic. And so I offer you the 10 things you hate about your API gateway. I hate the way you protect me and the way you filter calls. I hate the way you route my traffic. I hate it when you auth. I hate your dumb config files and the answers I cannot find. I hate you so much, it makes me sick. It even makes me rhyme. I hate the way you rewrite headers. I hate it when you job verify. I hate it when you make me laugh. Even worse, when you make me cry. I hate it when you're not online and the fact we can't receive HTTP calls. But mostly, I hate the way I don't hate you. Not even close, not even a little bit, not even at all. I'm Scott McAllister, developer advocate at ngrok. Happy to continue this conversation here in the hallway or on the socials, but thank you all for coming today.